Alright, so let's take a look at the fermentation of alcohols. So you may be aware of different processes that use fermentation. We can see here we've got winemaking, brewing, and bread making uses the process of fermentation to get the carbon dioxide to rise the bread, but then we cook off the alcohol when we bake the bread, so we no longer have any alcohol left in the bread. But it still uses the same process to get the bread to rise. Alright, so let's take a look at the fermentation process in more detail. So fermentation is an anaerobic process, so throughout this process we're getting glucose converted into ethanol and carbon dioxide. So yeast is the enzyme that converts glucose into ethanol and carbon dioxide, and we need some particular conditions for this. So we need an aqueous solution, and the bottom line is that yeast often comes as a powder, and so when we're using this yeast, we actually need it to be able to come into contact with the sugars. So if we think about sugar and yeast, if we mix two powders together, nothing's going to happen. So if we add some water or liquid to that, we're going to be able to make the yeast and sugar come into contact, and that's why we talk about an aqueous solution. We need an appropriate temperature, so some warmth, about 20 to 30 degrees. Enzymes are sensitive to the temperature, so they need to be at the appropriate temperature so that we don't denature the enzymes. It needs to be slightly acidic. Again, we need to have the right conditions for our enzymes because they are pH sensitive, and if they're in the wrong conditions then they will denature. And we need to avoid having any oxygen. So oxygen causes oxidation of the ethanol, and if we had that happen, we would end up with vinegar instead of ethanol, and that's not a desirable product. So I don't imagine that we would have too many people wanting to buy vinegar for the same price we have wanting to buy wine. So let's take a look at this in context. So brewing is one form of alcohol fermentation. So this is an end product of a home brew that I've made, and we can see here we've got a stout and that foam at the top, and we can see all those bubbles in there. That's the carbon dioxide that's made through the brewing process. We can also see here a fair bit of sediment on the bottom that's left over from the brew. Alright, so the first stage of the brew, we need to get our glucose out. So we can see here this is some grains that have been mashed, and what that basically means is that we soak these grains in an appropriate temperature, and I believe this one was 70 degrees Celsius. And in soaking it at that temperature, we're able to pull the sugars out of the grains and have them into a liquid form. Alright, so once we've got those sugars into the liquid, which we can see here, we boil it off to get rid of any existing bacteria. So boiling it takes this up to 100 degrees, which is perfect. That's what we want. We boil it for a particular period of time, and that cleans up our liquid. So it means that there's no more bacteria left. From there, we filter it and put it into a fermenter. So in this fermenter, we let it cool down to an appropriate temperature, and you can see here that there's a thermometer on the side. And this thermometer helps keep it regulated because remember, we don't want it getting too hot. And we add the yeast to this liquid. So remembering, we want that yeast to be in an aqueous solution, which this is predominantly the aqueous solution with the sugars from the grains. And we want to allow that to ferment for a period of time, so generally about 2 weeks. After we've fermented it, we then go through this process of bottling. So the bottling process, we put in a little bit of extra sugar, and that gives us more glucose and produces our carbon dioxide. And from there we end up waiting a fairly large amount of time, so a couple of months, before we end up with our beer.